All right. So, first thing first, few words about me. Actually, it has been much more than 20 years because I'm coming from Bulgaria, Eastern Europe, the land of yogurt, roses, and reverse engineered Apple II computers. I don't know how many of you know, but we have had a factory in a small city of Pravets where they made Apple II computers. So when I was 7 years old, I actually saw that computer for first time, and since then, this is my profession and everything I do. Currently, I'm software development manager at IBM. It took quite a long career path going through small startups that were two people to big company names. I also have PhD in informatics, and also I'm speaker, traveler, and also co-founder of two of the biggest conferences on the Balkans, QA Challenge Accepted and Dev Challenge Accepted. And I have to admit something to you. Actually, this year I was promoted to a manager and they took the most precious thing from me. They took me the QA team. So I'm no longer QA, but as you know, as there is no ex-policeman, there is also no ex-QA. On the personal side, uh, actually, I'm married. I'm proud father of two brilliant kids and one spoiled cat. I'm also traveler, photographer, and junior motorcyclist. This is my fourth time in Vilnius, and who knows? Maybe next time I come with my motorbike. So, okay, one important disclaimer so I can say whatever I want from now on. So, the views and the opinions I'm going to share are not related to my employer or any particular organization and may not match. Cool. Time for stories, right? And I actually will start the story with my wife. 2 weeks ago, she slipped. She fell badly. Her leg hurt. So we went to the emergency and made an X-ray image of her leg. Then we went to the doctor, waiting, and the doctor came out and said the following thing. He said, "You're lucky. There is nothing broken, nothing twisted. Still, you need to wait for 30 minutes for the results." And I was, why? Wait. You know that there is nothing broken, nothing twisted, and I still need to wait for 30 more minutes. How do you know that there is nothing broken? Because doctor said, actually, the X-ray is ready, the analysis is ready, but we have a very old CD burner that is just one speed, and we have to wait for half an hour to burn you the CD with the results. So you have this. And I was really surprised how something that small can cause that big problem, that big delay. Everything was ready within 3 minutes. The X-ray, the scan, and we had to wait for 27 more for the CD to burn. And actually, in our lives, it is often that something that is really tiny delays entire system really a lot. Uh, how many of you have been to the previous keynote, the Chris one? He had some stories. Okay, most of you. So thank you for being here. I also have some stories for you, and they're related to performance. I'll start with the year 1992. London, they are having a really nice ambulance coordination center with a really cutting edge software for the date. The thing is the software get overloaded, gets slow, and actually the chaos that it caused lasted for 3 days, and thousands of patients were reportedly dead because they didn't receive their medical help on time. We continue to 2013, NASDAQ. On August 22nd, it was freezing roughly for 3 hours because of overload and complete slowdown of their security information processor system. The result is millions, if not billions, of losses. Another sad story from 2018, Uber self-driving test car that was going to recognize a pedestrian. So the system was really slow. The pedestrian was actually pushing their bike, and the system was saying, this is a pedestrian, no, it is a cyclist, no, it is a pedestrian, no, it is a cyclist, and reacted, pushing the brakes only 1.3 seconds before the crash. So that was another case when software is slow, and this costs lives. Fail slow in data centers. There is a really interesting study. Basically, all the big companies in all the big data centers are having servers, routers, network cards, hard disk drives, and all of these gradually slow down. Some of these devices slow down to the uh, moment where they are completely frozen. However, uh, as they are still working, the system is not detecting them. And just imagine your servers starting to work 100 times slower because of a network car. Year 2020, COVID. It takes 1 minute because of slow software to access the medical profile. You can imagine what it was for the doctor. Thousands of patients needing immediate care, and every second is very crucial, and you wait for the medical profile to load. And 2022, DJI drones, they released a firmware update that made their drones react only 200 milliseconds slower. This was obviously enough for the drones to crash in different poles, fences, trees, and some of these were reported. Of course, DJI were forced to issue a corrective patch. And something that is another interesting thing, one of the big UK banks had a delay, technical issue according to them, but according to newlywed couple who had reserved a restaurant, actually this ruined their wedding. The venue did not receive the money, they canceled the reservation, so they ended up wedding at the parking lot instead of the restaurant because of that. And yeah, let's go 2025. Actually, in June there was a major slowdown, but to be honest, I experienced that yesterday as well. And actually, slowdown in ChatGPT didn't cause only ChatGPT to freeze. These are services like ChatGPT, OpenAI API, Microsoft Copilot, Bing, Snapchat, Duolingo, Notion, Khan Academy, Slack GPT, and many more. So basically, in complex system, it acts like a domino effect. Failure may not always start with a crash. It may start with a delay that quietly sets a chain of events no one sees until it is too late. Cool. Now, I want to raise your hand if, first, you have done any performance testing in the past 2 months. All right, I see about 15%. Hold your hands, please. Hold your hands. Keep them up if your team actually has some time or budget that is dedicated for performance testing. Others, okay, I see 3, 4, 5, 6, 7 hands. And keep it up if your tests automatically measure performance in your CI/CD pipeline. All right, 3, 4, 5 hands. Okay, 5 people in the entire room. Why is that? Why we never do it? Okay, it is expensive. When people hear about performance testing, they hear about a lot of time and investment, very powerful machines, what that need to simulate lot of users, lots of requests, and this is complex and often postponed. The other thing is many QA engineers simply love the idea but cannot do the setup. They don't understand the things. And actually, there is another reason. This is test trail. Look at that. We have passed, failed, blocked, but do you see any execution times? No. And the same is actually happening to practice test, to X-ray, to Mercury, to Q-test. All of these are just having passed, failed, and no times. So this is also a problem. Well, what happens when I go to my management and start talking about performance testing? Usually this opens actually a lot of doors. And those doors are the way out. Yeah. Why? Because we need to be cost effective. And usually there is no budget, no money, no time for that. Releases are coming. So what I usually hear is just see what you can do. And trust me, I have been working for so many companies in so many countries, and everywhere it is absolutely the same. Just see what you can do. That's it. All right, let's see what we can do. What if I tell you that every functional test could also be a performance test? Most of us are having automation that is up and running. It produces results. And all we need to do is to measure those tests and see if we can do something about that. Actually, the idea is really, really simple. We have some test execution. We put start and end timestamps. We have the duration. And basically, that's all. We know how much it takes, and we have a performance test. So that's it. Thank you. All right. No worries. Just kidding. But as a conference organizer myself, I can tell you that it is always the case when people are hearing to some boring guy speaking some stuff and then they hear applause. That's it. Oh, what's happening? So your applause for the technical crew of TestCon Europe. It is a hard job to do. All right. And happy birthday, TestCon, as well. 10 years. Wow. So let's continue. Is this idea a real performance testing? What do you think? Yes? Oh. Well, my answer is big no. It is not the real performance testing, and here I have to say it is absolutely not a replacement for the normal performance testing. Basically, if you imagine your performance testing like an athlete with nice body, what I'm proposing here is more like AliExpress performance testing. So it might not be the best, but considering the circumstances, considering your time and budget, it might still do the job. So actually, most of the tools we have, they have already some kind of field that catches time and execution duration. So for some of the tools, it's code time, for some is duration, for some is execution time, for some is execution underscore time. But basically, the idea is absolutely the same for all the tools. So this talk is not related to any particular tool. You can do it with anyone. All right. What I'm going to give you until the rest of my talk is actually 10 tips on how to make this idea actually working. So, first thing you need to do is pick your right tests. Those could be all of the tests, especially if you don't have such a big suite. It could be a specific, very important for you scenario, or it could be some kind of combination, smoke test. And the tricky part is you can measure everything. You may be actually already measuring it considering the previous slide. But you have to determine what you are going to track and inspect every day. Because small measurements every day will beat one big crisis test before the release. So, next thing is you need to add really lots of measurements. The same way you are putting asserts in your unit tests, you have to put measurements in your performance test. Let me give you an example. So, you have just, let's say, login test, which is you are entering the login details, pressing the login button, the dashboard loads, and then you get some stats. If you have stopwatches set only in the beginning and the end of this entire test, you can compare that it has been just 12.2% slower compared to yesterday. Good, but not enough. If you put much more stopwatches, you have much better granularity. And as you can see in this case, we can clearly see that the much slower part would be the main dashboard loading. So this is where we have to concentrate our investigation. Another thing that we should consider is we have to have only valid performance results. Only the passing functional tests should be used for performance data, and actually failing tests, they will tweak, they will distort your data, and that could be a problem in future. Basically, why I put the flat tire, the same way if you have your car with a flat tire and you are measuring it maximum speed, probably it will not reach it. So make sure everything is working okay, and then you can consider those as valid results. At least in most of the cases. I will give you more examples for that. So, next important thing is to set a baseline. Baseline is basically your reference speed or the first stable known good result. What does this mean? This means how fast your software works when everything is all right and you are getting the baseline. The same way, if you don't know what is the water level without waves, it is hard to measure the wave height. So you need to know how fast your software works. For instance, if you are having the login API, you start 5 runs. For instance, we get those at 2.2, 2.3, 2.2, 2.2, 2.1. Okay, the average is 2.2 seconds. So this is the normal performance. From there on, every time you run your test, you compare it to that baseline. Simple as that. Or almost. You need to keep that baseline alive. Because let's face it, you will get different security updates, some optimizations, some third-party libraries that get updated, and this will shift your timing permanently eventually. So frequently, you should do the so-called baseline recalibration and set it accordingly to what the new performance is doing. Something important, everything I'm going to say from now on, every tip I'm going to give is valid for both setting the baseline and the individual performance measurements. This is important. All right. You might also want to get rid of the noise. This is optional step, but what I mean. Imagine you have to send a request of e-commerce site where you have you want to know the top 100 people who have most orders, and you receive a response. Let's say it's a complicated system and it takes 17.4 seconds. But if you don't want to measure the time for connection, DB queries, you are just interested in the processing time, you can do the so-called bracketing, which means you try to send a null test, empty test, something like that. In this case, instead of 100, we say give me top 0 people with most orders, and you will eventually receive a response that is an empty list. If this takes 2.3 before the execution and 1.9, we get the average of those two. We get also the 100 people query, and we get the real processing time. For most of the cases, that works pretty well. So, another thing you need to have for your baseline is performance score. Of course, you can have many like this, but usually when you are reporting your team and your managers, they don't care too much about particular feature that has slowed down, although some of you as engineers will have to investigate that. But what your manager usually cares about, this is the total performance. So you should think, if you have, let's say, as here, test A and test B, you should have this performance score that can give you what you need. A tricky part here is that if you have many tests and you have really significant change, you might have a problem because it will be insignificant change in your performance score. And the way to do that is the most important tests, you put higher weights. But yeah, the idea, I have put these oranges and apples on purpose. The idea is to compare oranges to oranges and apples to apples. So try to find some kind of index of performance score so you know where you are. Now, let's see this example. We have 100%, then we have one slower test, and it became 136%. Is this good? Is this acceptable? Is this really bad and unacceptable? Here is why you need to put the so-called thresholds. Talking about the water level again, we can see on that bridge that we have level of the water that is in the green zone, in the yellow zone, and then we have a dangerous red zone. So we need to determine when is slow really slow. When we will say, okay, we have a problem. And here is the tricky part for you as engineers, because it really depends on your project. If we have 20% slower than the baseline and it is 2.2 seconds, we just calculate our thresholds. Okay, it is 2.64, so if it's 2.5, it's fine. 2.6 is borderline, 2.7 is warning. But where to put that threshold? I can give you nothing but advice from my own practice. For the critical features, put a smaller threshold. For the non-critical, you can be one idea more relaxed. So you can start with lower values, but if you are getting too many false positives, in the time you can adjust that threshold. But one more time, it really depends on your tests, on your environment, on your product, everything. I mentioned environment, so the next thing is always to run your tests in the same environment. Because let's face it, your local developer machine will probably uh, not be equal to the production environment as number of records, as as speed of processing, and what we need to do is to measure one consistent place and train the graph that will become really modern art if we are measuring on several different environments. Time of the day also matters. Trust me, having software in the day and having software in the night works completely different. Especially if it is, let's say, bank software. During the day, they have customers, they're processing something. During the night, they have different batches that are archiving and processing stuff. So this software will probably work completely different in terms of uh, latency and speed of processing. So consider to execute on the same environment, same time of the day, and also consider the time zones as well. I can give you an example in one of my previous companies. Uh, we were working in Bulgaria, and there had to be a backup that is cron job scheduled at specific time every day. And our DevOps team, they considered midnight GMT time. So when in London it is midnight, actually the system started the backup, everything slowed down, no one cared. Until we understood that we have very important customer in Japan. Because in Tokyo, at the same time, it is 8 o'clock. And you know how punctual the people in Japan are. 7:59, they are getting off the train. 8 o'clock, they are in the office. 8:01, they are logging in their system. And they are slow, deadly slow, because of the backup. So that is something that you should really consider. Another frequent problem is the phantom spike. So you have no code changes usually, but suddenly the system works slower or gives you slower results. Usually, in almost all of the cases, it is some external dependency, maintenance window, some jobs running, or downtime of your network, or very high CPU or disk load. So it could be any of these. Advice number 7. Repeat. You cannot trust a single run. You should always measure those tests more than once if you want to be reliable, if you want good results that can really give you some information. That is why you will need to run several iterations. Imagine the following. You have a very quick small test that takes usually 0.001 second, so 1,000th of the second. Then if this test for any reason, and it will happen almost always, takes 0.0012, this is actually a 20% difference. So usually the threshold will give you a warning and you will have a problem. So micro tests like this, you will have to repeat them many times in order to get some reliable results. And here is another thing that you need to determine as QA engineers, the balance between more repetitions and less repetitions. Because more repetitions will give you more reliability of your test, but will also mean slower execution. So depending on how much time you have to do those executions, you can decide how many times you would like to repeat those tests. But what is more important than that is to compare only what is consistent. What do I mean? Look at that guy, early in the morning, that lead. He's sleepy, he hasn't drank his coffee. he hasn't warmed up. Do you think he's going to make his first swap his best swap as well? Probably not. So same is with software, more or less. Sometimes software, most of many hard drives might be hibernating or sleeping. Some connections may not be established. So usually you need to run a few very basic, call them no tests if you want, just to make the system up and running again. Warm it and have all the caches, compilers, and connections working. Exception of that would be if you are testing exactly the caching functionality, but that's another story. What is the bottom line here is you need to avoid cold starts in measurements. Another thing that happens often is the following things. You get suddenly your test running like 20 times faster. So let's say the login test, it runs 2.2 seconds, 2.2, 2.2, and suddenly it takes, you haven't made any changes, but it is much, much faster. Well, usually 2000% faster means 100% wrong. Usually this is some database that is down and disconnecting, or you have really caching, or you have some system that is returning strange or empty responses. So be very careful and check that. Another important thing for people who love mathematics: use median, not mean average. What do I mean? Look at those tests I have taken from my previous example. So you have 2.1, 2.3, 2.2, 2.2, 2.2. In that case, everything is relatively consistent, and we see that both are the same, both are fine, the mean and the median. What happens, however, if we have one spike? In that case, if we are still measuring the mean average, our average time would be 3.18, which is not good for a baseline, right? To form your baseline, it is much better if you get the middle value, the median. So consider that when you are forming your baselines mostly. It makes a big difference. Next thing is, okay, you have that data, but you still need to make it visual. And here, I'm not going to limit you with use that and that or this and this tool. You can do whatever suits your team. You can have a simple Excel sheet, and you can go through all of your CI/CD tools. You can use Jenkins, GitLab. You can use test reporting tools like X-Ray Test Trail, or Allure, or whatever suits you. You can even use observability tools, Grafana, ELK, Prometheus. So the most important thing here is when something goes wrong, you to have easy way to see what has happened in the past, what is happening now, which tests have taken more time, and this is really, really important. And another thing was a mistake that I made in the beginning. We said, okay, if the test is slow, we should not allow the build at all. This didn't work well. There were many false positives. So what I would suggest to you is use warnings instead. And actually, the result of our effort was notification in Slack, like the one you are seeing on your right. So basically, every day you are getting something that is for each of the tests: better performance, same performance, or slow performance. Of course, you can exclude tests that are not working or having temporary problems. But in general, if you receive that on Slack, let's say every morning, you just have a very quick look and you see, okay, something is wrong with payment gateway and order history. And basically, that is my summary. So if you have to remember one slide from my entire talk, that's the slide. Start measuring duration for your existing tests as granular as possible. Pick the right tests, form a single performance score. From your baseline, that should be median based. Define a threshold for each test or the entire suite. Repeat those executions daily on the same environment, same time of the day, and consider only reliable passing tests. And don't be ignorant. If you see something is wrong, just investigate that. I will finish with the photo of that car. Looks nice, right? Yeah. So if we don't measure the performance, it is basically saying, okay, I'm fine with that card as soon as it takes me from point A to point B, no matter that its maximum speed is 20 kilometers per hour. Basically, we're doing this. And this is simply not enough in today's world. For every 100 milliseconds of added page load latency, Amazon reports losses of 1% in sales. You know how much is that and how much Amazon sells. Walmart, 1 second improvement in their page load time means 2% increase in conversions, according to their stats. 1 millisecond advantage in NASDAQ actually can generate millions of dollars per year. And let's talk about human lives. 2-second delay in the random refresh is already critical for safety. 0.1 second software reaction time in self-driving cars doubles the risk of a crash. So I started with such examples, and I want to finish with something very important, something that Chris put the fundamentals of, and I would back him up as well with my presentation. Such problems happen, and speed, quality, it is responsibility of our entire engineering team. But QAs are their last resort. They're the heroes, the quiet heroes, who can prevent the next performance disaster. So it's up to you if you want to be that hero or you want to be the reason for the next headline in the press that everyone will read about. Thank you very much. And yeah, if you can just leave the QR code again, the QR code, just to say something more from my presentation. Yeah, you can download the slides from this link, and there I also have PhD, and there is also scientific paper on that topic if you are more interested in the paper. Thanks one more time.
Thank you, Peter, for amazing talk. We have some questions in Slido. I want to give you a moment to upvote the ones that most interest you. And before I do that, we have an announcement. Someone has lost a Samsung phone in an OtterBox phone case. So if that's you, please go ahead and find the volunteers. And hopefully you'll get it back if you're able to identify it. All right, back to our Q&A. Our most upvoted question is, how would you account for the test framework's impact on the performance? Because that also takes a toll, I guess.
That is a very good question, actually. Test frameworks could affect the performance. That is why I said it is really good to have one empty or new test first to ignore the warming up initialization of the framework. And also, you can use the bracketing technique I mentioned. So you use that zero test to decrease the time of the remaining tests. If you do it enough times, it would be good. I think it will work. Next question.
All right. The next question is, how many iterations are enough for a performance test? Should a performance test also be a stress test? I think you partially answered that question, but maybe you could elaborate.
Yeah. My practice shows 3 to 5 is usually enough. It really depends on the product. However, should a performance test also be a stress test? Well, as long as it does not break the system, that could happen. But if it breaks the system, then we are reaching the flat tire case where we are measuring something that is not working. So that's my answer.
Yeah, if you make the environment fail totally, then your performance tests are pretty much over, right?
Yep.
All right, so let's take it a step further. So once we discover those performance issues, what are your suggestions on solving them? Someone is asking. We experience things like this. We experience like this is the most difficult thing when it comes to executing them.
Yeah. Well, finding the reason is maybe a good topic for entirely new talk about that.
So
But
part two coming next year.
yeah, but I will tell you one word uh, on the top of the regular investigation: do profiling. Google for profiling tools and see what can profiling do.
All right, we got some feedbacks on your talks. Some are very positive that it is very clear and good presentation.
Thank you.
Someone tried a code, it didn't work for them, so maybe you can find some time to debug that with the person. Come talk to Peter. All right, so someone is sharing that they have a struggle that they don't certainly know if the test CI/CD runner performance or the software performance. Any tips to investigate? Any tips
Yeah.
to identify which
Well,
is at
this
fault?
pretty much matches the testing framework one, whether it is the testing framework or the CI/CD tool. I would say the problems and the solutions to that are pretty much the same. So if you have any particular framework or tool in mind, do not hesitate to reach me and we can get deeper into that.